Welcome. Thank you for taking time to come hopefully learn something new or bring maybe a little different point of view. I will be walking you through everything. We are hearing a lot about Industry 4.0, smart this, smart that, industrial IoT. Normal IoT being added to industrial networks. So I'll walk you a little bit through what are the industrial environments, what are the representation if they are suitable for what is actually happening. I'll walk you a little bit through the changes that have been happening on the industrial side of things. And then I'll tell you a little bit about maybe how to protect them. So what are some of the things that you can advise to your customers or for you to understand a little bit better how to work in these evolving environments, I would say. So let's have a look at it. As I mentioned, this is the title of the talk, so I'll walk you straight to who I am. My name is Sarka. I actually started working more on the defensive side of things. I started in a team protecting critical national infrastructure. Then I moved to more the offensive side of things, where I am right now. I am involved in anything that's from social engineering, physical security, as well as industrial control systems. I'm teaching a lot, not only about that, but I'm also involved in everything that's healthcare and cybersecurity. I lead a team for Biohacking Village, which is a village that's all about cybersecurity and healthcare. So come and play. I have amazing team that are creating amazing challenges. So I work for Dreamlab Technologies. So I think one thing that I would definitely point out is important these days to have a partner who's neutral in the cyberspace. So I think that's one of the advantages. And you might be probably like familiar more on the Latin side of things, where we have a lots of our colleagues and very smart people. And we've been around for a while. You can see it here, and it obviously led also in our involvement in everything that's on the OT side of things in terms of partners, but also we have our own research team as well as doing the trainings, as I mentioned. So, what are industrial environments? How do they look like? What is actually changing? But I would start with something that I want to set a little right. Smart, in terms of smart, is not exactly correct, I would say. So I would say let's get this right. And I would rather say smart in this case would be connected. So I think it's important to actually, when you're talking to customers, they might not be aware because the smart notion might be misleading. So they should understand that instead of thinking of it as a shortcut or making things easier, it actually is bringing connectivity, which is good, but it needs to be done in a smart way. And that is the word that I'll be using for smart. Smart is smart, but in this case, it would be connected devices. And they need to understand all the vulnerabilities that come with it. So, what are OT or ICS? Because OT, the operational technology, is everything. It's an umbrella word for industrial control systems, as well as SCADA and distributed control systems. So where do we find them? We find them anywhere from processing our food, manufacturing plants, making our medicaments, but it also could be car manufacturing, as I mentioned. I am partially working on the healthcare side of things, and that is my big passion is actually the cross section of industrial control systems with healthcare. So that would be, for example, your hospital HVAC system. That is ICS, that is in healthcare environment, connecting two very vulnerable environments together. Oil pipeline, that might be another industrial control system, a water treatment facility, or power or nuclear plant. So these environments, the way that I'm putting it, there is a reason because for most of these environments, we have seen attacks in last couple years. When we are talking about car manufacturing, there was a ecans ransomware that was started end of 2019. We've seen it hitting big in the first half of 2020. And for example, Honda had to shut down their manufacturing plants all over the world for some time because ICANN's ransomware is actually one of the first. In reality, is second. First was Megacortex, but Megacortex didn't go as big. So ICANN's ransomware is considered to be one of the first ransomwares that are actually targeting industrial control devices, because most of the time, for example, our next example that I will give in a minute, it sort of attacks the IT part of things and then somehow gets to the industrial network. But econs, it's actually when it gets to the network, on its kill list are all the processes that are related to HMI. HMI is your human machine interface. This would be in your plant. There is this screen where you're seeing everything that's happening on in the plant. So all the processes that are happening there, you have all the data there. You could see it sometimes with like a big red button. In case something happens, you can stop it straight away. That's your HMI, or human machine interface, your window into whatever is happening in the processing plant. And that is what they were targeting, because obviously if you shut down the like their view into the processes, whatever is happening there, they can't do anything. So that was the ecans ransomware. As I mentioned, the second one is ransomware 2. So there was a Colonial Pipeline ransomware attack that's 4 months back. So there was a dark side group, which is ransomware as a service group, that attacked them. Unfortunately, Colonial Pipeline, it's about 45% of the East Coast fuel, and so that's your everything for your car, all the way to jet fueler and military supplies out. So there was more that didn't target exactly the that came through the IT side of things. Another one was, so when we were looking at the water treatment facility, so water treatment facility in Florida, the attack was, I believe, a disgruntled employee who connected through TeamViewer to HMI. Remember, that's the window into your processes. So connected remotely to that and changed the chemical that's used for cleaning the pipes. And the person changed it from 100 parts per million to 11,100 parts million. What it means, if it would not be caught, that means that that person would poison the people. So we are seeing the growth of attacks on these environments, and it's, well, we obviously were more familiar with the nation side of things, so like Stuxnet and the attacks on the power grid in Ukraine. But recently we are seeing more of a criminal approach in attacking these environments, because obviously it's an environment when if they attack it, they most likely will want to pay to get it back up. So this is the representation of the usual representation of these environments. So this is your computer integrated model, the SIM or Purdue model. This was created in 90s, so 1990. And it represents this automation pyramid. And the idea is, so on your level 0, you have your production processes. Then on top of the processes, so let's say process is mixing chemicals. On top of the process, so that on the level 1, you have the sensors and actuators. So that's whatever sensors are sensing whatever is happening there. Then on the first level, that's your sensor. On the next level, you would have a PLC. So then it's communicating. It's like PLC, it's programmable logic control. It's like your like an industrial computer. Very simple. There is something programmed. So when it senses, it sends to the PLC. The PLC then uses the actuator. So you have sensors and actuators. So that could be like your valve with the chemical that needs to be added. So then you have the process, the sensors, actuators, PLCs. Then on top of that, you have the HMIs, your human machine interface. So it sees whatever is happening below that we just discussed. Then we would have, for example, a historian. That's your database. So that's all the data about everything that's happening. That's usually being replicated, for example, in because that's the level 3. So then you would have between the level 3 and 4, you would have usually DMC. So it could be replicated in a one-way fashion, or at least should be. And then it could be sometimes even replicated on the IT business side, which is the top of the pyramid. That's your level 4. By the way, sometimes you might see 5 levels. It differs why, and that's sort of where I'm trying to get. This pyramid is supposed to tell you that this is a way how to also secure things, or this is your threat modeling, because it says to use security controls, security in depth on every layer, as well as most of the attackers would come from the IT side, so from top of the pyramid. Does that really represent what is happening since the 90s? Because we've been progressing quite a lot, and we've been adding lots of these connected devices, right? So I would say it looks maybe more like this, because we are seeing the convergence of the IT and OT. The lines uh, between themselves are blurring. It's like the pyramid, it's not exactly the representation of it, because we are seeing more heterogeneous and complex environments, because all of these different devices that are being added to obviously make it work better or have better overview whenever whatever is happening. So IT versus OT. So IT, we know, right? That's your these are your computers and servers, and it has all these firewalls and antiviruses with the protocols HTTPS, SSH. On the OT side of things, we are seeing less screens, with it's more industrial. But in terms of devices, it's all of a sudden it's PLCs, your programmable logic controller, or sensors or actuators. And also in terms of the protocols, we have protocols like Modbus, S7, Profinet, and these lack lots of security controls. So the approach has to be different, because we can't be protecting and securing these environments in the same way. So what I've been trying to get to is that perhaps the SIM or the Purdue model that is still being used as like a reference architecture everywhere is perhaps not completely right, because I would say it's your ICS from 90s. So it's hierarchical. There is this hierarchy in the levels, and so it's not exactly working lately, because we are seeing, for example, everything that's like your cloud-based big data analytics for we need predictions, right? So we need the raw data from the lower levels of the automation pyramid when we are talking about the pyramid. So we are connected to that, and it's being directly uploaded to the cloud, and it's not then the as I mentioned, the assumption when in the security of this is that it's the top level, it's where the where the threats are coming from. But we are seeing more network flows, and that are also traversing the different levels at once. They're just like skipping them. We are seeing more complex deployment, which obviously, again, connectivity usually means increase of vulnerabilities. And we are also seeing more technologies like wireless, portable technologies, because, for example, when I was talking about the PLC, the equivalent of PLC, sort of the same function, is RTU, that's your remote terminal unit. But for example, RTU would be something that you put in an outstation somewhere, electrical on station, where it would be connected via wireless. It would be using a solar. It would be solar powered. So it's all these new technologies that it's all of a sudden the attacker is not exactly gonna come from the top of the pyramid. So the pyramid is sort of like not working in this matter. Then we are also talking about new technology. So there is TSN, so that's your time sensitive networking. So we are there is IEEE, a working group that's proposed this set of new ways how the not only the industrial networks could work, but that would mean it actually speeding up. In terms of the TSN, actually, currently there is only Profinet and OPC that implemented it, but I still wanted to mention it here and to explain you. I think I like to really explain it on this Profinet part, because it shows nice actually going from, so currently most of the uh, typical Profinet. So Profinet is suite of a different protocols. So for example, your IO Profinet, that's your input output, that's your peripherals. So that would be a protocol that you're using for your PLCs or RTUs. But there is also the alarms and record. So it's this suite. But this one is using TCP/UDP, and it's for non-time critical tasks, because it means since they are using IP-based communication, it's not exactly suited for time critical tasks. So what happens then? Then I want you to look the next part is the RT, IRT, and the TSN. We are working towards the TSN. So RT, Profinet RT is the Profinet real time. So but it doesn't stop there in the real time. Actually, IRT, which isochronous real time. So that's for high speed motion control applications. So that's sort of like the newest, the most of like the fastest way of using this, because the asynchronous one is using. There is lots of less collisions. That's how it was built. But so it employs the IRT and RT for real-time channels. So that's when we need something that's time critical application, because what you're seeing is actually skipping the TCP/IP layers, and so it's avoiding that time and that communication on the protocol stack. So then we are moving towards the TSN. In reality, as I mentioned, Profinet and OPC UA were the only ones that have implemented, but it's not exactly there yet, because it has to be properly implemented in all the components. You can, for example, use the TSN Profinet devices with non-TSN Profinet devices, but you will not benefit completely the whole network from TSN. So it's not there yet. It's sort of like where it's going. And where I'm trying to get to is then the automation pyramid. It's probably not the best representation for how this network will look like. I really like the approach of Mondrian and Tableau. So I will explain a little bit about that. It's a research that was published last year was Mondrian and Tableau is this year. So it's these are the new architecture. So Mondrian is the architecture for enterprise or IT networks, and they took it and on top of it built a Tableau, which is the one for OT networks. So Mondrian is actually a painter from, I believe, Netherlands. Tableau is actually one of his the art pieces that he did. Someone must like him very much. So why did they feel the need to actually first build this flat zoning architecture that you're seeing here on the Mondrian side of things? Because even the IT infrastructure is becoming a lot more hybrid and very heterogeneous and very complex. So this then needs a different approach than how it has been. And actually, that sounds a lot like the OT environment that we just talked about. Keep the hold to the thought because that is actually why they then use Mondrian to use Tableau or on the OT side of things. So what you're seeing the Mondrian partitions, then into the zones that you're like seeing the zone 1, zone 2. So it partitions the network into these collections of flat zones. And as you can see on the picture, maybe it's here for you. Each of the zones it's connected to this designated security gateway that they are calling TP or transition point. So the zones are connected to these transition points, and then the same logical zone, like you're seeing the zone 1, zone 2, or zone 3, it can be distributed across different branch sites. For example, here you're seeing the zones 1 and 3 being distributed across a main data center and the branch site. So the next part that I want you to sort of focus on is actually the main building block of this concept, and that is this interdomain that is happening between the transition points. So I will talk to you a little bit about that in a minute. Actually, in the paper, I really liked this more up-to-date Purdue model. So because here you're, again, remember I told you sometimes it's 4, sometimes it's 5. Here they have actually 5 layers, but it uses also the external offices that are then on sort of connected to the whole model. So since in the standard Mondrian deployment, remember that the flat zoning, all the network zones are connected to the same TP, the transition point. Remember, there were these two TPs. So then it's connected to the internet, and as we saw before, this results in a flat zone architecture. So how do you translate this flat layout to what actually Purdue model is very hierarchical, right? So we have a look. Now this is a proposed that's the final the Tableau proposed architecture based on the Mondrian. So the Tableau then splits the network in the multiple device or host zones. You're seeing that every host or device zone is guarded or has the Mondrian transit point, and then it's on at the edge of each of these zones. So then when the traffic leaves the zone, the TP then encapsulates it and then uses an encrypted and authenticated tunnel and forwards the traffic wherever it needs to go. So some of the differences that you might see here is, for example, it merged the Purdue levels and placed the field devices, which are your sensors and actuators, remember, place them into one with the controllers. So that would be your PLC. Uh, Why? Because the communication between is very critical, so they put them together. Also, what is new is the integration of the IT zone. So you're seeing the office on the right side of the picture. So since the Mondrian was originally designed for IT networks, it obviously we can include them. So it's adding the IT zone just as another, well, here we call them host or device zones, but it's just another zone, right? So it sort of works like Lego. Same as including the office zone, just as another office zone, we can be talking about remote zone. So, for example, when we have SCADA, that's SCADA is normally spread across geographical locations. So, in this case, it's great because you can add the different. Let's say it's a water treatment facility or outstations. You can add them just as a remote zone to this infrastructure, to this representation or this new kind of architecture model. So I think we are moving towards people understanding and proposing new ways how to shape the system. And this is not only how to build them, but this is also how to approach all the security. So how smart is the industry 4.0? So I will explain you what actually industry 4.0 mean and how we got here. So first we had the first industrial revolution. What you're actually seeing is the first steam engine from 18th century because they had lots of flooding. So they and especially in mines. So Thomas Newcomen actually built this steam engine to pump the water out, and that's how it all started. So here the first industrial revolution is just the use of machinery to help humans. When we were talking about the second industrial revolution, so that's your technological revolution. So here we introduce new ways how to work and live because all of a sudden we have electricity and light and we can work longer, but we can also we build a railroad so we can connect to each other, we can sell things and move goods and telegraph, so we were able to call each other and talk to each other. And when we are talking about electrification, your factories. So the factories would have electricity, which meant light, working longer, and production lines creation. So then the latest and greatest what we are living right now is the third industrial revolution, and that's your digital revolution. So what it really is, that is the shift from the mechanical to the analog electronic technology to the digital electronics we use today. So that's your computerization of everything, the digitalization. That is where we are living right now, but we are hearing a lot about Industry 4.0. Indeed, it was originated in Germany in 2011, so a little while ago, because it is an approach from a German government that is promoting the computerization, but where we were before being helped by the computers, now it's sort of moving like us helping the computers taking lots of load from us and being more maybe self-sustaining. So this, which is why we're talking about AI and machine learning, cyber physical systems. So it's everything, the systems that where the change in the cyber side of things will produce a physical change in the physical environment. And that's where the smart factory came from. So that is where we are sort of heading. And that's why I was saying, what's the reality? The reality is that the purely smart factory was built only 2 years ago in US. So most of the environments that you will be seeing when we are talking about OT or ICS is not as connected. And the truth is actually we are just adding these connected devices, so it's creating this like a hybrid environments, which have obviously their own issues. So remember this? This is still where we are. So how to be smarter, and here I mean not to be more connected necessarily. It's more about understanding what is it that we have. Understanding that we are just not, we don't want to tell our companies or our clients to just add these devices. We need to understand what is happening, that perhaps these environments will vary a lot. So you might get into an environment that has lots of legacy devices, but you might also get into something, maybe it's a completely really new, smart, connected factory. So it's about understanding. And for example, these days, research showed that 75% of the CISO are worried about nation state attacks. I mean, it could be that your client is a nuclear power plant and it's a critical national infrastructure, but in most cases, it's really uh, making making them understand that they need to get the basic rights, and that's the sort of the reality where we are in these networks, because we need to go from the basics, because in most of the cases they start adding these connected devices while they didn't set the basics right. So what are the basics? You start about, I think, knowing how to be smarter. It's about knowing yourself first. So you need to understand what is it that's are in the network. What kind of network are we talking about? A network that is somewhat heterogeneous, or are we actually thinking about a network that's still maybe working on a serial connections, and we want to add some connectivity? So we need to understand what is it that we have, what are the parameter devices, what is it inside the network. Some of the most common issues that we are actually seeing, it's like a weaknesses in the network segmentation. Remember, I told you, I think the part where I really like the tableau approach, it's segmenting the network, and segmentation is one of the approaches that we tell our customers to do, because okay, it goes back to, for example, one of the approaches is air gapping, right? Air gapping is this isolation from internet, and the idea is right, but on average, there are 11 direct connections on an air-gapped network. So you need to approach it with the breach principle. So understanding that you are most probably breached and just looking for the indicators of a compromise. And one of the ways how what we recommend is the network segmentation, because it's great from a point of view of security. So if one network segment gets breached, not necessarily the other segments gets breached, but it's also great when we are talking about patching, which is another issue in this network. Use of insecure protocols. Again, you need to understand what kind of protocols you have. We are seeing very similar weaknesses in terms of the industrial protocols. So it's lots of times it's vulnerability to denial of service. So you need to segment it, or you need to set up the devices so they can't dose the rest of the network. We are seeing lots of it is lacking encryption. So again, you need to be careful. But there are more secure protocols like OPC UA, I mentioned it here, or BACnet, that are these days the new iterations. For example, BACnet SC was only released last year. They are built with security by design, but they need to be securely. So that's again another issue. I mentioned the patching is another issue, we are seeing about 70% of the OS used in these environments is actually unsupported. And you need to count with that. Again, you can segment the network securely, but you need to understand yourself and the network that you have there. Credential management would be another issue that we are seeing a lot, especially the isolation of credential management between IT and OT side, because you need to separate that. And yep, it's not. It goes back to awareness. They need to the guys in these uh, power stations that they need to understand why is it that they need to use different passwords for their industrial computer that's connected to the industrial network and their normal computer they use to receive emails. So okay, you first understand your internal threat landscape or your customer. The next one I'm very passionate about is the human threat landscape. I think we are sort of forgetting about this part a lot, even on the IT side of things. But insider incidents were actually 60% malicious insiders and about 40% negligence. So that tells you a lot that that might be actually something that you want to look into. As I mentioned, I believe the security awareness in these environments it's not always done right, because you need to make difference between someone who sits in a normal IT business network and someone who sits in an outstation and dealing with all the OT stuff. Um, Insider threat has been raising recently because again, it's perhaps easier to coerce someone into do something like this. But I think you can just fight this by being a little bit more kind. I believe that we are still seeing a lack of technological support for the humans in our network, and that's part of it. Like you should look at your human threat landscape, but you should not forget about the technological support of those humans there. And processes and procedures. For example, use of USBs or personal devices. I understand that someone might be angry that they can't bring their normal future phone, so like your smartphone, connected phone. But you need to make them, again, that goes back to the security awareness. They need to understand why they can't bring it, because that's bringing in a USB. That's how Stuxnet happened. Um, Okay, so we understood our internal threat landscape, our human threat landscape. So then it's the external threat landscape. So where is the attack surface? Again, it goes back to the fact, how does your environment look like? Does it look like is it older environment that really suits the Purdue model, or are we moving towards more like the tableau or the one in between where we have where we are connecting to cloud-based analytics, for example, and we are still to even like the lower levels of the processes. So we need to look at that and understand that where is it that the threats could come from. For example, Shodan. If you go to Shodan, you will see lots of ICS exposed devices. For example, the HMIs, remember the human machine interface. You can find a lots of them there, and unfortunately, it is possible. And I please don't do that. You can just click on them, and there is start, stop buttons, but you don't know what it's going to do. So this is important. I believe there are tools that you can where you can be guarding your infrastructure, and if it doesn't come up and it's not exposed on internet or accessible over internet. So you need to look at your access control weaknesses. You need to look at the hardening of your network, same as the devices, because then it might just open some ports that it shouldn't. And since it is industrial network, you also need to look at your devices such as PLCs or HMIs if they are not somewhat exposed. So We understood internal human threat landscape, external threat landscape, and now we need to know how to prioritize things. So we need to understand what is important, what parts and functions of the networks we need to maintain for it to work. Depending again, is it a food plant? So maybe it's a rather business issue, or if it's is it a nuclear plant where it would become a safety issues with if something happens. So what are your crown jewels, and so where do you put more attention to? What do you really need to maintain at all cost? Then I would say on the rise we've seen lots of supply chain attacks, so that is something. It goes from who you work with towards, for example, there has been latest research, for example, in libraries in OPCUA that then in the end there was a remote code execution. So again, supply chain attacks are another part of the issues that we should look at when we are talking about the libraries. SBOM, your service bill of materials, you should be aware of and used in these networks. And then obviously, once you build over that, you know about all your thread landscapes, you need someone to test it and be aware using things like there is a Mitra attack for ICS. It's a great way how to use it as a training tool or as a gap analysis tool, and then you obviously test your network. And I would like to think that we are getting there after some certain maturity. You can use things like honeypots, and it's a great tool. But again, I said it needs some maturity. You can't use it just like this. But then understanding what is your threat landscape like. If you are mirroring the system that you have, you get then intelligence about. Is it someone who's just scanning internet, or is it coming from certain geolocation? So that is probably your sort of in this ecosystem of how to protect these environments. That would be your last step, and then it's rinse and repeat pretty much. So that was it. I am not sure if there's Q&A, but thank you so much for taking time. And I'm here. Ask me anything. You have the Twitter handle is there are three underscores and three after, so you can just ping me on Twitter. Thank you.